has instructed state authorities to step up genome sequencing of COVID cases in view of a sudden spurt in COVID-19 cases in China and other parts of the world. All organisms have a unique genetic code. The genome is composed of the nucleotide bases. Now, this helps identify unique DNA fingerprints and patterns which help determine the order of bases, and therefore that's exactly what's called genome sequencing in layman terms. It determines the order of the bases in a particular genome. The genome sequencing is a process which is conducted in 4 stages, namely DNA sharing, DNA barcoding, DNA sequencing, as well as data analysis. Now, we'll in fact go through the details of what this process actually entails. The Genomics Consortium for SARS-CoV-2, which was actually set up in December 2020, is where the genome sequencing is actually undertaken. And to explain to us the details of the specific process, we're currently joined by Dr. Saumitra Das, who's the former director of the National Institute of Biomedical Genomics. Dr. Das, thank you so much for speaking to us. Now, of course, when the centers come out with a certain direction to states to send positive case samples for further genome sequencing, if you could just explain to our viewers the significance of the step and in perfectly layman terms, what does this process actually entail?
See, as you have already mentioned, that the virus has its own genome, which is an RNA genome, and it's an RNA virus. And it's no surprise that when they copy their genome, they just do mistakes. And there are mutations gets incorporated into the genome. When there are too many mutations, then it gets into a different lineages. And then if there are original mutations are replaced by fresh mutations or different kind of mutations, it can lead to a different variants. Now, with these changes in the genome structure, the characteristics and the property of the virus also changes. Sometimes it becomes more transmissible, sometimes it becomes more virulent, sometimes it becomes less virulent. So all these things happens. But how do we know that? So what we do is essentially we collect samples from different centers or different places. And then we try to isolate the RNA, viral RNA from there, which is done for the RT-PCR to make sure that the person is actually RT-PCR positive. That means the viral genome is there in that patient. And then that RNA, we actually make a cDNA library out of that. And then we try to make the sequence. We try to decipher the sequence of the genome. As you just rightly mentioned, that actually differs from one to the others. And where are the changes, whether that changes is going to change the character of the virus is something that we look for. And then we try to correlate with the patient scenario, whether the patient is hospitalized or it's not really severe, but it's actually mild. So those kind of things that we try to have a correlations.
Okay, so Dr. Das, just to take this forward and again to explain to our viewers, what is the significance of this entire step? Now, does it actually mean that we'll be able to determine the behavior of the virus in question, its virility, its intensity, and also possibly whether or not it has the potential to mutate into something more lethal? Is that the purpose of this entire exercise, sir?
See, the purpose is different purposes. The first purpose is just to know that the variant that is in the circulation, is it very different from the one that we have been experiencing? The second thing is, if we find it is very different, obvious question is it now have more affinity towards the receptor to enter into the host cells? That means its transmissibility or infectivity has increased manifold or not. Second thing is, we have to check that we are all immunized, either by natural infection or by vaccinations. Whether this new variant is going to be neutralized by our antibodies that is raised against the natural infection or by the vaccines, that is the second question. So when we have a new variant isolated or detected, we try to find out whether it has the ability to escape the immune challenge, whether it has more virulence or transmissibility, what is the RO factor, whether it is going to infect more people, and then we try to raise an alarm if we find that something is not in the expected line and very unusual things are happening.
Okay, so one follow-up question to that. assuming that some random samples are collected, some of them turn out to be positive, and the positive samples, as instructed by the Health Ministry, will be sent to INSACOG for genome sequencing. They suspect that it could be the B7 variant, which is of course heavily prevalent in China and of course also prevalent in India since the month of September. So therefore, how does the process now go forward once those positive samples that have been collected have been sent to INSACOG?
See, we have started with the 10 centers, as you said, INSACOG started with the 10 centers. Now we have 58 centers in India, all over every places. So the samples are collected and then actually taken out to the one of those regional sequencing centers, RGSLs. And then that sequence information is actually shared with the central database where it comes and deposited, and we analyzed it very carefully and find out whether this sequence has anything that is something to be raising alarm, or you see something unusual pattern in that particular sequence or not. So we try to find out whether this is of the same variant or it's actually a different things that we are watching from that particular zone. Then we try to have a little additional sequencing to find out whether that is something to related with the surge in that particular pocket or not.
Okay, you managed to actually deconstruct a very complicated process there in very simplistic terms for us, sir. Thank you so much. But let me take this across to Kritsveen as well, who's joining us for some more details on how